Hello, Algebra 2 students. This video lesson is going to be about parabolas, and the parabola is a conic section that is formed when you slice a conic diagonally. Right here you can see where this cone is being cut diagonally. And so what's formed here is a parabola. So we're going to be looking at some different aspects of the parabola as a conic section. And so this picture we have right here of a parabola is very familiar looking. This should look like a very familiar shape that you're used to when we worked with quadratics. And so some of these attributes of the parabola you already know. You know that the parabola forms a U-shaped graph. You know that the parabola is symmetric about the axis of symmetry. The axis of symmetry goes through the center of the parabola and also it goes through the vertex, which is the minimal or maximum point depending on which way the parabola is opening. Now this particular parabola is opening up, so we have a vertex that is a minimum. So what we're going to learn today is what a focus is and a directrix. So a parabola can be drawn using the vertex, the focus, and the directrix to give it its shape. So that's what we're going to talk about today, and we're going to find these different values given an equation in standard form. Notice that the vertex is located at the midpoint between the focus and the directrix. So here we have the vertex, here we have a focus point or focal point, and here we have a line called the directrix. And we can use this focus and directrix to draw our parabola. So the distance from the parabola shape right here is the same distance from the parabola to the focus as from the parabola to the directrix. So anywhere I go along this parabola, I should be able to put a point, and that distance from the point to the focus and the point to the directrix should be exactly the same length. So this is what happens when we are drawing the parabola from the focus and the directrix. So as we go up and up and up, this length right here, as you can see, this dotted line right here, is going to be the same length as this dotted line right here. Okay, so also notice that the distance from the focus to any point on the parabola is equal to the distance from that point to the directrix. Okay, so that was what I just pointed out. We can determine the coordinates of the focus and the equation of the directrix given the equation of the parabola. So when I give you the equation of the parabola, we'll be able to use some formulas and find the different values for the axis of symmetry, the vertex, the focus, and the directrix. And that's what we're going to be doing today. All right, now you're going to find that this table is very handy. I also gave you a hard copy of some notes that I made for you to use as well to help you when you're working these problems. But this table is also very helpful, and you should keep it handy so that you can refer back to it. The general form of the parabola is going to be this ax squared plus by squared plus cx plus dy plus e. And the way you're going to see the equations that I'm going to give you on the worksheet are just x squared plus x plus e, or y squared plus y plus e. So you'll see when we get to that those examples here in just a moment. The vertex form of the equation is this, and we're not using this vertex form today, But I do want you to notice this right here. This y equals 1 over 4p. Notice how this is the same thing as a. And that is very important because we're going to use this right here to find a value called p. And this value of p is actually the distance from the focus to the vertex and from the vertex to the directrix. And that value is always positive, a positive number, because we're measuring distance, and distance is always measured as the absolute value of the distance between the point and the end point. So direction of opening, it's going to open vertical if p is greater than 0, and it's going to open down if p is less than 0. If it's horizontal, if it's a horizontal parabola, in other words, if it's opening sideways, left to right, if it opens right, then p is greater than 0. If it opens left, then p is less than 0. So really the positive or negative just gives us the direction of the parabola, not necessarily that it's a negative distance, because there's really no such thing as a negative distance. So it's just telling us which direction the parabola opens, whether it opens up or down or left and right. Okay, the vertex is HK, which you probably already knew that. Whether it opens left or right or up and down, this point right here is going to be still going to be HK no matter what. H is going to be your X and K is going to be your Y for that coordinate. Axis of symmetry is going to be X equals H for parabolas that open up and down. And for parabolas that open sideways, Y equals K is going to be your axis of symmetry. So this becomes very important when we're, especially when we start working with the sideways parabolas, because that is something that you're not used to working with. So just keep in mind that there are some parabolas that open left and right. So these values will be determined by that. All right, so the focus. The focus is going to be the point, the same X value that's your vertex has, okay? But the Y value is going to be the K value for your vertex plus P. That's going to give you your focus. For the parabola that opens sideways, it's going to be H plus P first. That's going to be the X value, and then K, the Y value. For the directrix, for a parabola that opens up or down, Y equals K minus P is going to be the equation for your directrix. And for the parabola that opens left and right, it's going to be X equals H minus P. So it depends. You have to pay very close attention when you're working with these left and right parabolas to make sure that you're not getting this confused with this. All right, so I'm going to use problem number 1 from your worksheet to explain how to find all of the parts of our parabola that we need. So first of all, we're going to find the axis of symmetry by using our axis of symmetry formula. Then we're going to find the vertex. Then we'll find the value of P, then the focus, and then the directrix. All right, so let me just walk you real quickly through what I've done here. Okay, first of all, I found the axis of symmetry by using the formula negative b over 2a. So the axis of symmetry is negative 12 because b is negative 12. A negative 12 is a positive 12 over 2 times 2, a is 2, 2 times 2 is 4. So 12 over 4 is 3. So x equals 3 is our axis of symmetry. So if I wanted to graph that, I would go ahead and just put a dashed line showing that I have an axis of symmetry at x equals 3. So I can start my graph with my axis of symmetry. The next thing I found was the vertex. So you use this 3 to plug into your equation here everywhere there's an x. So that's what I did right here. I plugged a 3 in, I substituted the 3 in for x, and I got the value -4 for y. So for my vertex, my coordinate is 3, -4. So I can go ahead and put that value in, 3, -4. That's about right here. So there's my vertex. The next thing that I did was I found the value for P. Now P is the distance from the vertex to the focus. It's also the distance from the vertex to the directrix. So in order to find the focus and the directrix, I need to find the value of P. And the formula for finding the value of P is 1 over 4 times A. Well, we know A is 2, so 1 over 4 times 2 equals 1/8. So the distance from the focus to the vertex is very, very small. 1/8 is not very big, and on this graph it's going to be very hard to try to draw that in, because even my dot right here is bigger than that. 1/8 would be about right there, and then 1/8 in the other direction would be right there. So that's really, really, really tight. But we're going to go ahead and try to graph it anyway. Okay, so I'm going to put a dot right there to show that that's my focus. And my directrix is going to be a line somewhere right in here. Now the directrix is perpendicular to my axis of symmetry. So that directrix line should be perpendicular to the axis of symmetry. So to get the value for the focus and the directrix, the focus is going to be the same x value that was the x value for my vertex and my axis of symmetry. It's going to be the same x value because it's located on this same line. But the y value is going to be different. I'm going to take my y value from my vertex and I'm going to add the length of P to that. So -4 plus 1/8 gives me -31 over 8. So that's going to be kind of hard to graph on this teeny tiny graph, but I tried my best. It's about right there. And then the directrix is a line. In this case, it's a horizontal line because it runs perpendicular to my axis of symmetry, which is a vertical line. So my directrix is a horizontal line, and it's in the opposite direction from my vertex that my focus is. Okay, but it's the same distance. So it's 1/8 away from my vertex. So I did the best I could is draw a line here to show this directrix. And that is 1/8 away from the vertex in the opposite direction from the focus. And the equation for this line is y equals -33 over 8. Because I take my value for k, which was my -4, and I subtract p, which is 1/8. So -4 minus 1/8 gave me a -33 over 8. And this is all you need to find for this particular problem. The only other thing we want to do is go ahead and draw in a sketch of our parabola. And so we want to put in a couple other points for our parabola. So if I go to the right 1 unit and up 2, I should get another point for my parabola. And if I go to the left 1 unit and up 2, I should get another point. And it should be symmetric about the axis of symmetry. So I'm going to draw my parabola in right here like this. So once I find a point on one side of the parabola, it'll be easy for me to find a point on the other side of the parabola because it's symmetric. So once I know one point, I can find the other. Now we're going to take a look at number 5. This one is a parabola that opens to the right. And the reason I know that opens to the right is because of this x equals. So if your equation starts with x equals, it means that your parabola is going to open either to the left or to the right. If this value right here is positive, then it's opening to the right. If that value was negative, it would be opening to the left. So in this problem, we're going to find the same values we were looking for before. We're going to find the axis of symmetry. the vertex, the value for P, and the focus and the directrix. All right, the axis of symmetry is found the same way. So I'm going to work this all out by hand, and then I'll walk you through what I did. All right, so I've worked through everything. My axis of symmetry is going to be calculated the same way I did the other one. It's going to be negative b over 2a. So negative 3, a minus a negative 3, because this is a negative 3 for b, minus a negative 3 over 2 times 1/4. Well, 2 times 1/4 is just 1/2. So when I multiply by the reciprocal, I get y equals 6. So y equals 6 is this axis of symmetry right here for this parabola. The next thing I do is find out where is the vertex? So the vertex in this case is going to be somewhere on this axis of symmetry. So I know that the y value for my vertex is 6. So I plug that value of 6 into my equation for y, and I calculate that through, and I get negative 4. So at the point negative 4 for x and 6 for y, I have my vertex. So let's go ahead and graph that one. I'm going to do blue this time. So negative 4, 6. 1, 2, 3, 4. It's going to be about right here. That's where the vertex is. The next thing I want to calculate is the value for P. How far away from the vertex is my focal point or my focus and my directrix, or the line that's perpendicular to my axis of symmetry. So to find the focus, I know that my y value is going to be 6 because the focus is also on my axis of symmetry. So I need to find where the x value would be. Well, I take my x value of negative 4 and I add p. So negative 4 plus 1 gives me a negative 3. So I know that my focal point is going to be at negative 3, 6. So at negative 3, 6, I'm going to put a focal point. And that's also located on my axis of symmetry. Now the directrix is going to be the line that's perpendicular to my axis of symmetry, but is in the opposite direction from my focal point. From the vertex, it's going to be the same distance. So one unit back would be right here, and I'm going to draw this directrix line in here. Now this line is an x equals line. So this particular line is going to be x equals negative 5, because what I have to do is I have to take my x value right here of my vertex and I need to subtract 1 because I'm going in the opposite direction. So negative 4 minus 1 gives me a negative 5. And I draw my directrix right here. This is my directrix. X equals a negative 5. Now the next thing I need to do is go ahead and draw in some values for my parabola. All right, so the next thing I want to do is find another point on my parabola. So I want to try to find a value that will be easily divided by 4. So if I make y equal 2, then if I square 2, I get 4, and 4 divided by 4 is 1. So I'm going to use the value of 2 for y to find this other point. So when I plug in my value of 2, I get 1/4, I'm going to write it down here, 1/4 times 2 squared minus 3 times 2 plus 5. This actually gives me the value of 0, because this gives me 1 minus 6 is negative 5 plus 5 is 0. So at the point 0, 2, because remember I plugged a 2 in for y, At the point 0, 2, I have another point on my parabola. So here's another point on my parabola. So this parabola is actually opening this way, to the right. And so if I had enough space here, it probably would be, symmetrically, it would be 4 units away from the axis of symmetry in this direction, and it would go out this way. So there would be the graph of my parabola on this particular equation. So basically that's it. So the only thing you need to worry about or be careful about is if you've got a parabola that's opening downward, the values are going to change. Watch out for the negative signs. And if the parabola is open to the left also, you're going to have a negative value for A. So just watch out for that and make sure you don't make any mistakes with those negatives. Try a couple of these graphs. If you have difficulty with them, please bring your questions to class on Thursday when I will return, and we will go over a couple of examples during our very short time together on Thursday. So good luck, and I hope you all have a great day.